Now, we proceed to another discussion of basic integration, and let's focus involving logarithmic function and exponential function. In this video, we are going to tackle about indefinite integration involving logarithmic function or ln. So, to formally start our discussion, let's have this example. At first, we have the integration of 1 over x dx. So, based on the law of exponent, we can write it as this, x raised to negative 1. Therefore, the value per n here is negative 1. So we have x raised to negative 1 plus 1 over negative 1 plus 1. So, what happened? It will become x raised to 0 over 0. So, this value is undefined. So, the question for now is, what is the value of the integration of 1 over x dx? And that is the question. In order to understand this concept, let's try to have a general expression for this integration. Let's try this general expression. So we have the general expression, the integration of 1 over u du. And the rule, the answer is ln u plus c. And that is the general expression. Let's apply this expression. Let's say we have 1 over x dx. So our answer is ln x plus c, since the value of u here is x. So that is the answer. Let's try another example, wherein we have the integration of 1 over x plus 2 dx. Our u here is x plus 2. So we have ln x plus 2 plus c, because it is indefinite integrals. Okay, let's try another example. Now we have 1 over x plus 3, or let's say x plus 5. So, in this example, the value of u here is x plus 5. So we have ln x plus 5 plus c. Now, let's have another example. By this time, we have the integration of 4 over x minus 2 dx. As we can see, we can move on the left side the constant 4. So we can have 4 times the integration of 1 over x minus 2 dx. Then, the next thing we are going to do is just simply 4 times the integration of 1 over x minus 2 is equal to ln x minus 2 plus c. So we can distribute the value of 4. So we have 4 ln x minus 2. Since it is constant, we just simply add plus c. So that is the answer. Now, let's try about the indefinite integration of exponential function. To understand this concept, let's have different examples and general expressions for this integration. And to formally start our discussion, now let's have this example. We have the general expression, the integration of e raised to u du is equal to e raised to u over the derivative of u plus c, because it is indefinite integral. So, let's have an example. Let's say we have e raised to 4x dx. So, just simply copy e raised to 4x, then the derivative of 4x is 4 plus c. Then, this is our answer. Now, let's try another example. By this time, we have e raised to 6x dx. So, we have e raised to 6x, and the derivative of 6x is 6 plus c. So, that is our final answer. Now, let's try this one. We have the integration of e raised to x dx. So, our u here is x. So, what we do is just simply e raised to x, then the derivative of x is 1 plus c. So, simplify it. We have e raised to x plus c. And that is our final answer. Now, let's try another example. And by this time, let's combine the exponential function and the constant. So we have the integration of 6e raised to 2x dx. The first thing we need to do is just simply put on the left side the constant. So it will become 6 times the integration of e raised to 2x dx. The next step is just simply get the integration of e raised to 2x. And by this time, the answer is 6 times e raised to 2x. And the derivative of 2x is 2. Then, simplify it. We can cancel it. Therefore, we end up on the answer, which is 3e raised to 2x plus c. So, that is our final answer. Now, try it on your own. You can pause the video if you want to answer this first, and then continue to check your answer. So by this time, we have the integration of 8e raised to 2x dx. Then, put the constant on the left side of the integration symbol. Then, we have this. Become 8 times the integration of e raised to 2x dx. Then, we get 8 times e raised to 2x over 2. Then, we can simplify it. So, we have 4e raised to 2x plus c. So, that is our final answer.